Alright, so here's your Digital Learning Day lesson. It's got a little bit of review of what we've been doing the past few classes, as well as some tie-in to what we're going to be doing over the next couple of classes. So, in this 3 problems right here, you may want to pause the video and try these 3 problems before you move on through the video and see the solutions. It'll be good practice, good review. Number 1, you're dividing using long division. So we're going to take and make our division house. On the inside, we're going to put the dividend, the thing we're dividing into, x squared minus 7x minus 12. Notice that there are no missing terms, so we don't need to fill in 0 for anything. On the outside of the division house, we're going to put x plus 5. Again, there's no missing terms, but you can see here that we have the divisor, the thing we're dividing by, on the outside of the house. Yes, technically you could use synthetic division on this particular problem, but I want to practice long division a couple of times, or one time in this video. We want to keep practicing it several times though throughout the chapter so we know how to do it still. So remember, with long division, you always take the first one on the inside divided by the first one on the outside. X squared divided by x is going to be x. That is our first term in our answer. Remember, you can always double check yourself in the next step here, because the next step is to multiply this times both of these. If you multiply x times x, you get x squared. X times 5, you get 5x. The first one will always be the same if you did your first step of division correct. Also, on your next step with subtraction, remember you're subtracting this whole entire polynomial. So if you subtract that whole thing, this is going to become negative. This is going to become negative. You should see that your first term always cancels out. If it doesn't, you did all of it wrong on that first little step of dividing and getting x. Negative 7x and negative 5x does not cancel. That's negative 12x. And then we bring down the negative 12 to the next step. With long division, basically you just repeat the same process again. You take the first one on the inside divided by the first one on the outside. Meaning you take the negative 12x, that's the first one on the inside here, divided by x, the first one on the outside, just like you did before. So that gives me negative 12 when you cancel out the x's. Negative 12 is going to be the next term in our answer. Again, you multiply. Negative 12 times x is negative 12x. Negative 12 times 5 is negative 60. And then you subtract everything. So that's going to cancel out the first one because it'll make it positive. But it's going to be a positive 60 and a negative 12, which is actually 48. That is my remainder. There's a couple of reasons I know that. Typically, you'll be at the end of your house when that happens. Also, this degree here is 48x to the 0 power, so the degree is 0. As soon as the degree gets lower than this degree you're dividing by, which is x to the first power, you know you're done. So, our remainder here is 48. Because it has a remainder, we've talked about that over the last few classes, what that tells me is that x plus 5, the thing I was dividing by, is not a factor. That doesn't change the fact that if I took x minus 12 times x plus 5, the thing I was dividing by, and added the remainder back to it, I would still get what I started with. That's how division works. But it means that it's not a perfect factor, so that's why I have to add this remainder back to it. We will see some that are perfect factors here in just a little bit. The second problem is dividing using synthetic division. Remember, synthetic division basically also has its own little house. On the inside, though, with the 2x cubed, 6x squared, and minus 9, we don't have to put the x's actually in here. We just put the coefficients of 2, 6, 0, and negative 9. Now, some of you may be thinking, if you didn't pay attention in class, why in the world did he put 0? Remember, we put the 0 there because there is no x to the first power right here, and so we have to have a placeholder for it, just like we do with long division. Synthetic division is based off of something called the remainder theorem. We're going to kind of mention him again here in a little bit as well. But the remainder theorem says if you divide by something simple, like x plus a number or x minus a number, you can find the remainder if you plug in the opposite of what you're dividing by. Or in other words, if you're dividing by x plus 2, if you plug in negative 2, you'll get the remainder. That's why it's called the remainder theorem. A neat byproduct of this remainder theorem is it also gives me what's on top of the house of division here at the bottom of this little house. So if I divide by x plus 2 here, I plug in negative 2. The first step with synthetic division is always to bring down the 2 to the bottom. Then all we have to remember at that point is to multiply and add until you're done. Now I'm going to draw a couple little arrows here, but I'm not going to do this every one. But if you multiply negative 2 times 2, you get the answer of negative 4. That answer is added to the next number. 6 plus negative 4 is 2. And then you just repeat the process, multiplying by the outside number over here, and then adding it to the next one. So negative 2 times 2 again is negative 4. Adding it to this one is going to be negative 4. Negative 2 times negative 4 is positive 8. You get a negative 1. This last number over here is always going to be your remainder. Your terms on the inside here, 2, 2, and negative 4, on the bottom of my house, are always going to start 1 degree lower than the thing that I was dividing into, my dividend. In other words, the answer on top of the house. Because you're dividing 2x cubed by x to the first power, you get 2x squared to start. It's always in standard form, so you can always go backwards as well. Negative 1 being the remainder, this being the constant term, x to the first term, x to the second, and it would keep going up. So this would be my answer. If I divided using long division, this would be the thing that's on top of the house with my remainder negative 1 way down here at the bottom. Notice again, it's still a remainder, so that means this does not divide evenly. X plus 2 does not divide into 2x cubed plus 6x squared minus 9. If you use this synthetic division on the last problem we just did, you'd see the same thing. At the bottom of the house, you would have a 1 here, a negative 12, and then a remainder of 48. You could double check this and do this yourself if you'd like to see that it does work. The last little review problem that you saw on this page over here is describing the end behavior. Notice that the degree of this one is 4, which is an even degree. That means it's going to act just like the quadratics. The negative 2 tells me that both ends of this are going to go down just like a quadratic parabola that's opening down. The only difference is if we graph the rest of this, we'd probably have some other curves in the middle. But we're not worried about that. All I'm asking you for is the end behavior. So, dividing is useful to see if something's a factor. But the really good thing about dividing is that it also is useful to actually factor things that don't fit. Our nice little patterns, factor by grouping, factoring like the old quadratics, or factoring with a sum of cubes or difference of cubes. If it doesn't fit one of those patterns, division can also help me factor. Because if you get something that divides without a remainder, then you know the thing you divided by is a factor, and the thing that you got as your answer is a factor. Again, kind of going back to this one that we looked at right here, we divided by x plus 5. We got x minus 12, but there was a remainder. So we know that x minus 12 times x plus 5 is going to be close to this, but we have to add 48 to get us actually to this. Real quickly, I'm going to show you what that looks like. X times x is x squared. X times 5 is 5x. Negative 12 times x is negative 12x. Negative 12 times 5 is negative 60. Then if you add 48 to that, you're going to have x squared minus 7x minus 12. That's what we started with. What's going to be great is when we have remainders of nothing, we'll actually have two factors sitting here that multiply to give me what I started with. The tricky part is knowing what actually is a factor. And so what I'm going to get you to practice over the next couple of slides and on a couple of homework problems, just a few, is I'm going to tell you what's a factor. The way I'm going to tell you that is through another little theorem. It's called the factor theorem. We've actually talked about this theorem a little bit in class already, but I want to review it with you in this video and take the time to review it here because then it'll tie in closely with the things that we look at over the next couple of classes before our test. The factor theorem basically is kind of like the remainder theorem, and it ties very closely with the remainder theorem. The remainder theorem says if you want to know the remainder, you plug in the opposite of the number you're dividing by, and it'll tell you the remainder. Well, what the factor theorem says is a polynomial has a factor if and if, only if, you plug in that number that's in the opposite of this, and you get 0. In other words, if you plug in 6 and you get 0, that means x minus 6 is a factor. It means it divides evenly. Because the remainder theorem says if I plug in the opposite of this, which is 6, I'll get the remainder. Well, if the remainder is 0, then that means it's a factor. So if you know something that makes it equal 0, you know a factor. If you know a factor, you should know something that makes the function equal 0. So again, here in the red down here, I've got that summarized again. So if we know the zeros of the function, then we know one of the factors which will divide into the polynomial. Then we can use polynomial division, long division or synthetic, to factor the polynomial. So if we know something that makes it 0, then we know a factor. If we know a factor, we can use division to find the other factor. Let's just go to something real simple. What's a factor of 28? 4, you may say. If you divide 28 by 4, you get 7. You divided it by a factor, and you got the other factor. 4 times 7 is 28. So we're going to do the same thing, but we're going to do this with polynomials. Your first example. This problem says to factor the polynomial x cubed minus 2x squared minus 19x plus 20, given that f of 5 equals 0. Let's just go back for just a second. If you tried to do the factor by grouping method on this one, you would be able to take out x squared out of these two, but the only thing that you could take out of here is negative 1, and you would have a positive 19x minus 20. This is not the same as this. That means it doesn't factor by grouping. So we're left with an issue. We can't factor it with our pattern. But you are given something in the problem. In the problem, you are given that f of 5 equals 0. That means when you plug in 5 to this function right here, and right here, it'll cancel everything out and it's 0. What that means for me is by the factor theorem, if I know something that makes it equal 0, I know the opposite is a factor. So if 5 makes it 0, what's the factor? You're right. X minus 5 would be the factor. Now, if you didn't say that out loud, that's okay. But x minus 5 would be a factor. Now, what I want you to do here at this point in the video is pause the video and divide this function by x minus 5. Remember, that means we can use our good old handy-dandy synthetic division. So divide it quickly here by x minus 5. When you divide it by x minus 5, you're going to put 1, -2, -19, and 20 across the top row. That's the thing I'm dividing into. You're going to put +5 right here. This is going to be the trickiest part for a lot of you guys, because if you're looking at it, 5 makes the function equal 0, which means x minus 5 is a factor. But 5 is still what I want to plug in to my synthetic division, because when you divide using synthetic division, you always use the opposite of the factor. That's a little tricky there because you kind of got to go back and forth in your brain a little bit with some mental gymnastics there. Then you bring down the 1 to the bottom and you multiply and add. 5 times 1 is 5. -2 plus 5 is 3. 5 times 3 is 15. -19 and 15 is -4. 5 times -4 is -20. 20 and -20 is 0. What you should notice there is that is a remainder of 0. That's what we were expecting, because we know that x minus 5 is a factor. What's the answer down here? Well, the answer is always 1 less than this. So it's going to be 1x squared plus 3x minus 4 with a remainder of nothing. Now, you don't have to put the remainder of nothing, because then that would just be the answer here. But that's not the answer to what this problem wants me to do. This problem wants me to factor this. So think back over here to what we did with regular division when they didn't have a remainder of 0. We said that if you divided by x plus 5 and got x minus 12 with a remainder of 48, that means x minus 12 times x plus 5 plus the remainder is what you started with right here. Well, the same thing applies here, but now it's even better. Because if we divide this guy right here, this polynomial, by x minus 5, that means I can divide it out to the front of the problem and write what's left over. Well, the leftover is your other answer that you get when you divide. So when you divide by x minus 5 here, that is going to give you this answer. That means x squared plus 3x minus 4 is my other factor. It's just like when you take 28 divided by 4 and you get 7. 4 times 7 is 28. If you divide x minus 5 and you get this, that means this times this equals that. Now, I'm not going to take the time to do that right now, but if you distributed this x to all three of these, distributed this -5 to all three of these, you would end up collecting like terms to this. You just factored a polynomial using division. Now, notice that the one on the right there can be split up some more. You can actually split this up a little bit more. And so what we're going to want to do when we are factoring something is be able to factor it completely. Not just use the division to help us get that first part done, but also be able to split this up further into x and x, plus and minus because it's a -4, and then the factors of 4, 1 and 4, I'll put a 4 here and a 1 here to get 3 in the middle. So this times this times this gives me what I started with. What we just did was we used division to help us factor something that is not one of our pretty patterns. X minus 5 we knew was a factor because 5 made the function 0. So over the next couple of classes, we're going to talk about how in the world did Mr. Harrison get this? How did he know that 5 was going to make it 0 before the problem even started? That's what I'm going to teach you to do over the next couple of classes. So let's do one more to practice, and then I'll leave you some for practice for homework. So given that f of negative 3 equals 0, factor this polynomial f of x equals x cubed minus 6x squared minus 13x plus 42. So what I want you to do is go ahead and think about what that first statement tells me. If I know negative 3 makes it equal 0, what do I know about a factor? Think about it. So what does it tell me? If negative 3 makes it 0, that means x plus 3 is a factor. Now guys, let's talk about real quick how I know that. Remember when we were setting up our little factors and we set them equal to 0? The reason that we know x plus 3 equals 0 would be a factor, because if you solve that, negative 3 would be the thing that makes it equal 0. So that's how we know. Now that's what the remainder theorem and factor theorem say together, basically. So if you know negative 3 makes it equal 0, you know x plus 3 is a factor. Since I know that x plus 3 is a factor, now what I want you to do is to take this big function here and use division with x plus 3 to help you find the rest of the factors. Pause the video here and try it first before you watch. Then I'll give you the solution, and then you can try the other ones on your own for homework. Since I know that x plus 3 is a factor, I'm going to divide using synthetic division, because that's the easiest one. And I can because it's x plus a number. But I'm going to put negative 3 on the outside. Notice on the inside I put my coefficients from this. Notice there's none missing. We bring down the 1 and we multiply and add. What is negative 3 times 1? Negative 3. Negative 6 plus negative 3 is negative 9. Negative 3 times negative 9 is positive 27. Negative 13 plus 27 is 14. Negative 3 times 14 is negative 42. These cancel out to nothing. That's what we expect because we knew that x plus 3 was a factor. When we plug in negative 3, we should get 0 here because the remainder when you have a factor is nothing. The answer would be x squared minus 9x plus 14. That is my other factor. That means this polynomial splits up into x plus 3 times x squared minus 9x plus 14. Now, if you haven't done it already, take the right-hand part and split this one up using our old quadratic patterns. Hopefully, now that you've already done that, now you should be able to check your answer here. X and x. Plus tells me my signs are going to be the same. The minus in the middle tells me they're both going to be negative. A negative times a negative is a positive. But it'll also give me the negative in the middle when I collect like terms. What's the factors of 14 that give me 9? 2 and 7. Now, if you think about it, if you go back to thinking about this process that we talked about over here of setting things equal to 0, if you were to set this equal to 0, obviously negative 3 is one of your answers. But if you set this equal to 0, 2 is another one. Set this equal to 0, 7 is another one. So it all ties back to that solving stuff that we did earlier in the quadratics chapter. If you know something that makes the function equal 0, you know a factor. If you know a factor now, you can use division to help you find the other factors. Okay, so on the next slide, what I have for you is your homework problems. There are 5 of them. On 2 of them, I've already given you what one of the factors is. You just have to use your division to help you find the other factors. On the other 3, I've given you the information that you learned in this video. If you know something that makes it equal 0, then you know a factor. So these homework problems will be turned in to me, And this will be your proof that you went through and did the digital learning day. Please, please, please watch the video.